In this film I show you how to make a support that can rotate and translate. On this side on the hole I just made a pinned constraint, that's the pinned constraint, and you see it in here. On the other side I introduced a cylindrical constraint with this function. I used the following loads. I introduced a bearing load on this side, and I introduced a load on this side. So that's flexion, like you see, and that's compression. I just go back to the FEM file. In the FEM file I make a 3D swept mesh. That's a hexahedron mesh. You see here hexahedron 20 with mid nodes. You take here multi-body infer target. You choose a surface. Global size I do on this solid 2.5 millimeters. You find the files in the Moodle. So I'll make the mesh. You see every element is a cube. It's a hexahedron. It has 6 surfaces. I just go back to the simulation. I let run the solution. I just control if everything is okay. So I have results. I look in the results. I made 2 load cases. One is the compression load case, the other the flexion load case. I look at the flexion. Everything seems to work. I look at the displacement in compression, and there, if you look at it, it's quite bizarre, and it's also very strange, the size of the deformation. So your thesis side, it's just turning but not moving. We should have compression. We have to define that in another way. I look at the constraints. This cylindrical constraint I remove and I replace it by a constraint with capacity to rotate and to translate. For this thing I have to use 1D connection. In this 1D connection I take point to face. I use the type RBE3, that's a rigid beam element with initial point and end point. I say on this point I take the source point in the center and I put it to this cylinder. So I have made a 1D connection from the center to every node on the cylinder surface. Now I have the possibility to define with user-defined constraint just for this point here. I fix everything, but I leave open the deformation in x direction. Degree of freedom 1 is x direction, and I let rotate it around the z coordinates. That's the degree 6 rotation around z. Okay, I introduced that. I let run the solution. I just control if there is everything okay. There is no errors, no warnings, so it's fine. I go to the results. In the results I see that in the displacement everything okay. It's just making this flexion and turning, and in the compression you see I have compression. So you have seen how to introduce support that's possible to translate and to rotate. That's just this support, this gliding support we had in a lot of cases as we calculated the forces. So that's all I wanted to show you. You learned how to make in the FEM file 1D connection and how to make on a point a user-defined constraint in giving free the x direction, the translation, and the y rotation. On a point that's possible. On the 3D elements it's not possible to use something from the rotation, but here the point translates it to the whole surface. That's the 1D connection, in English also called multi-point constraint. That's all.